Hello, everybody. My name is John Wolthuis. I'm a co-founder and product architect here at Twilio. The name of today's talk is The Art of the Possible. So what does that actually mean? To me, I'm going to be talking about the API design philosophy here at Twilio and how that attempts to minimize the impossible. I'm going to spend a few minutes talking about our API design philosophy, and then Gowri is going to take over and talk through some customer examples and how they are leveraging our APIs to do interesting things. If you have any feedback during the talk, please text the code to the short code there. I think you guys probably know this by now. So let's get started. So the art of the possible is basically about composability and designing APIs to be highly composable. You probably got this from Jeff's talk, a little bit of the idea about composable APIs sitting on top of frameworks and underlying software stacks. The first thing you have to think about when designing a composable API is developers. Developers are very smart, very imaginative, creative, and unpredictable people. They will think of a million ways of using your API that you never intended, never anticipated. But a well-designed API is going to not stand in their way as they are coming up with these crazy ideas. It's gonna be flexible enough to adapt to things you didn't foresee. But you have to actually design for composability in that manner. One of the things that you really need to focus on is focus. You have to, when you are designing your API, you need to make sure that it is just doing the kind of unique challenges that you are trying to address. It's not trying to do too much or trying to reach too far into other stacks. Composable APIs are meant to be working alongside other pieces of software. The idea is web development and mobile development isn't on a single stack anymore, and it hasn't been for a long time. You're picking and choosing the tools you use. You're composing these tools together to create a full-featured and flexible and very interesting application. So only do what you're good at. A little bit of back history here. In 2007, when we were getting started building the company, we didn't really have the idea for Twilio as it stands right away. We really did a lot of brainstorming around different types of software products. We wanted to mash up telecom with web applications because we knew that was a really, really big problem based on our previous experiences. But we started by thinking of just ideas that we wanted to do. We had a dozen brainstormed ideas, like IVRs for family reunions and voice broadcast systems and disposable phone numbers and joke lines and things like that. When we looked across all these examples, we realized that there's a one piece in each of those products that we couldn't actually solve ourselves yet with the existing tool set. And the more we looked at that, the more I thought that was a really, really interesting idea. That's a problem that really needs to be solved, and that's kind of how Twilio was born. So when we started doing the actual design of Twilio, we had this huge set of example ideas to work with. And what we basically did was go through, and this is up here on the slide, is the initial version of Twilio. That was really all it had, all the functionality it had. We looked at about all the examples that we came up with, and we picked a functionality set that would cover about 80% of the use cases. This is something we call the 80-20 rule, and it's sort of a rule of thumb for doing initial API design, where you don't want to actually try and go for 100% a match with every possible use case you can think of, because you're going to have a lot of complexity trying to handle all those long tail use cases. What you want to pick is a good 80% sort of as a rule of thumb. And if you can cover that with your API functionality, then you've covered a very large use case set, and your API is still very narrow and simple and sort of approachable. This is in contrast to kind of how telecom stacks worked at the time when we got started. They tended to be full stack implementations. You had a piece of hardware or you had a software package which you had to do all of your development in. It's meant to host the entire application. The APIs it exposed tended to be use case APIs, not sort of building blocks, which meant that you had a voicemail API or a company directory API or an ACDQ API. You didn't have more atomic pieces that you could then assemble and compose with your other software packages into kind of the user experience that you wanted. Integration tended to be an afterthought as well. You could maybe at some point make a connection out to a database or connection out to a third-party application and pull in some account information or a balance or something like that and integrate it into your flow. but it wasn't sort of the primary way it was designed. It wasn't meant to be worked into the rest of the software in your company. And that's kind of why when you call into an older, large IVR system, you have to give them your account information like 3 times every time you change get handed off and transferred to a different person, because it's not a tightly coupled integrated system. The things designed this way are poorly composable in that they're not really meant to be used alongside other software in your system. Another thing you have to really tackle when you're designing an API for composability is embracing web standards. The assumption should be that your developers are going to be developing it directly against your API. They're not going to have a native helper library or something like that. This really is all about making it possible for people who are using different stacks or different languages. There's a new like developer stack or new language that's popular like every 30 minutes these days, it seems. And you don't want to have to go and build out all the application libraries to actually integrate those into your system. You want to have people have the freedom to understand your API and be able to integrate with them without having to intervene with you at all. The best way to do this is to really stick to like common internet protocols. We use HTTP for pretty much everything we do, unless there's a good use case for something else, like a WebSocket for an event stream, or SIP for like session setup. But HTTP is basically king. Everybody knows how to talk to HTTP. It's a very simple, very powerful protocol. It's extremely well understood. You can write a client for Twilio or an HTTP interface in Haskell or Perl or Python or COBOL if you want, and it's going to be a very low learning curve for any developer trying to access your API. In the same theme, you should also use a consistent API format. We like REST. We think it's very approachable and very easy to consume. Other people use SOAP. It's a little bit more heavyweight, but it has some advantages as well. But you should basically pick something and be consistent, and so that way your users don't have much of a learning curve to actually start consuming your API. And then another just sort of small thing is just use a well-known serialization format. Use JSON or XML. Don't come up with your own serialization format. You see this a lot in like some of the telecom stacks that you see. They have a custom like binary or text data feed. That just aids in the allowing new stacks and new languages to talk to your API. You don't want to have somebody have to write a builder and a parser and a validator for your message format. Use something off the shelf. You're not going to get an advantage like doing it yourself unless you're doing some really crazy high performance stuff. Another topic that you should address is configuration. You should try and minimize or eliminate any kind of configuration that's required to use your API. It's just kind of a barrier to entry. If you look at Twilio's, like our phone number example for an incoming phone number, there's only 2 real bits of configuration you need. You actually need to go and buy the phone number and add it to your account, and then you need to point it at your web application. So basically, from a Twilio perspective, we receive the call, we pass it off to your application, and then all the application information and the behavior of your application and the configuration is all defined in your software. You can look at a 1,000-person call center or a joke line and look at it in the Twilio environment. From the configuration we have, we really can't tell the difference. And you don't want to have a customer come back into your system and ask permission or modify systems to get this kind of functionality. You should really try and avoid it. It makes it far more composable. So basically, require the minimum if you require anything at all. You should also always allow configuration of the API, configuration if you require it through the API. It's a good thing to have to let people, if they think of an interesting use case, be able to come in and programmatically modify that in the API. You don't want to have somebody have to go into the account portal and make a manual change. Either it will prevent their use case, or worse, they'll come up with some sort of scraping technology to go into your account portal and try and make those programmatic changes themselves. And that's, you don't want that and they don't want that. So try and allow as much API configuration as possible. There's some cases where you wouldn't want to do this for security reasons or just for administrative reasons, but it's something you should probably really strive for. Another concept is favoring ad hoc just-in-time configuration. An example of this is like our conferencing service. You don't have to go and load all the possible conference rooms you ever want to join. You don't have to go and pre-create those in Twilio. Basically, the act of saying, I want to join conference room sales or conference room number 127, if it didn't exist before, it creates it just on the fly, and you can start moving from there. It basically makes the API a lot more composable, a lot more flexible, because you don't have to worry about syncing your application state and data objects with Twilio in order to do sort of shared things. We also use this pattern in the SDK client endpoints. If you have a user in your system, if you, let's say you have Alice and Bob in your system, and these have rich sort of data objects on your side, you have a lot of profile information and a lot of authentication information. If you want to reference those in Twilio to set up video endpoints or client endpoints, you're basically just saying, I want to create an address that is a placeholder sort of proxy for Bob or Alice in our system, and you want to keep the rich portion of the data object on your side. You don't want to have this copied and synced between the two, because that basically is a barrier to entry for developers developing across your platform, and it's a very hard problem for them to kind of solve. Finally, one of the things it's really not really an API design aspect as much as it's sort of a business model aspect, but you really want to have low friction access to your API. This means people, if they have a crazy idea and they want to see if your API is a fit for it, they need to be able to sign up and start using it right away. So a free trial and pay-as-you-go pricing makes this very, very easy. A free trial lets them try it out a little bit, kick the tires. But pay-as-you-go pricing, if they don't have to negotiate like a package of minutes or a long-term contract when you're signing up for this, it really lets people experiment. And the more people can experiment, the more they can try different things that they're not sure are possible or not. And you really want to make sure that people understand that they can try out these crazy ideas. There's no risk to them. Alongside the pay-as-you-go pricing, one thing you always want to have in place are some custom spending controls. If you have, this is basically to protect people from either the failure of their application or the success of their application. If something goes wrong, if they have an infinite loop, you want to be able to set a ceiling about how much you want to spend, how many times you want to recharge their credit card, things like that. But if they get on TechCrunch and they have a huge amount of incoming traffic and they want to be able to keep that up and running, you want to make sure that it will still, it won't go down because they've run out of money. You want to let them choose how they want to behave during success and failure. So have some controls in place to control how the auto refresh happens and how the payment gets processed. So that's basically just a quick run through of just some basic best practices for doing composable APIs. And I'm going to hand it off to Gowri now, who's going to talk about some of our customers and kind of how they've used the APIs that we provided in this manner to build some interesting things.
All right, thanks, John. So I'm Gowri Grewal. I lead the sales engineering and the solutions architect team at Twilio. And I'm going to talk to you about a few customer examples. So you've just heard from John, who is one of Twilio's founders, about how we built Twilio with composability, configuration, and low friction access in mind. And I'm going to pull out a couple of interesting customer examples that show how customers are using Twilio to build great things. So Cargurus is a customer of ours that connects car buyers with the best deals in their area on new or used cars. They've solved multiple communication challenges with Twilio. So when a customer sees a car that they like on Cargurus, they're presented with a couple of different options to contact the dealer. They can either put in their email address and wait for an email response, or if they want to talk to the dealer right away, there's this button at the top which says call the dealer. So Cargurus has composed this experience through Twilio. The customer enters their phone number and then waits for a call back from the dealer. So let's take a look at how this actually works with the Twilio API. As soon as the customer clicks that submit button with their phone number, this kicks off an HTTP request to the Twilio phone number that's associated with the dealer for that car. So Twilio calls the dealer, and in this leg of the call, they actually pass contextual information about exactly which car that user is interested in. Once the dealer accepts the call, then Twilio connects them with the customer, and they're able to talk. So another way that Cargurus uses Twilio is, let's say you see a car, but you don't want to necessarily talk to the dealer right away. So they give you this option to actually send the link to that car to your phone. So what happens in this case is you can send the link either to your phone or to a friend or perhaps your spouse. And then Cargurus can use behavioral analytics on the back end to actually track user engagement and optimize their site. So it's this combination of the email channel and the voice channel, the SMS messages, and the backend analytics that really show how Cargurus has used this composability aspect of the Twilio API to design the communication experience that they need for their customers. So let's take a look at another example. Lyft is a popular ride-sharing service that connects riders with available drivers. They also use a variety of Twilio services, and they really take advantage of the aspect of the Twilio API that John talked about with minimal configuration and doing configuration through the API. So let's take a look at how Lyft works with Twilio. When a passenger first requests a ride, they are given the option to connect directly with a driver. One of Lyft's goals in creating this customer experience is actually to create a sense of security and community between the passenger and the driver. And so this voice call is actually put through while Twilio is masking the phone numbers. So each party is connected through the Twilio phone number that's assigned to that specific ride, and they're without needing to know the actual phone number of the other party. This communication stays live for the duration of that ride, and then as soon as the ride is over, the connection is severed and privacy is restored. So this did a lot for creating that sense of privacy, trust, and community between the riders and the drivers. But then Lyft faced another challenge. They found that about 10% of their support calls were actually coming in because of lost items that were left in the cars. So the old way that Lyft used to deal with this was that you'd get out of the car, you'd realize you lost your item, you'd have to call Lyft customer support. The support agent would then contact the driver with a description of the item. The driver would look for the item and have to return it back to Lyft headquarters. And then somebody at Lyft headquarters would actually mail the item back to you at your house. So you can see this was a little bit inefficient, and it was also very costly for Lyft to have such a large percentage of their support agents working on these type of issues. So they solved this problem with Twilio. So now, as soon as you finish your ride, you get a link, you get a receipt that has a link to it, that is a link to report a lost item. So if you have a lost item, you enter the description of the item, click submit, and this kicks off an SMS message directly to the driver of your ride. The driver can then communicate directly with you, again, just for the duration of this lost item communication. This allows the driver and the rider to actually communicate in real time, arrange a convenient place to pick up or drop off the item, and then as soon as the item is picked up or dropped off, the communication is severed again and privacy is restored. So there's actually one more interesting way that Lyft uses Twilio, and that is that they use SMS as a fallback for when their drivers are no longer in good cell range. So the way that the Lyft service works is that a driver will sign in and indicate that he's available to accept rides. And then the Lyft service, the Lyft application, will periodically send updates on the driver's location back to the server so that rides can be scheduled in the most efficient way. But if the Lyft application sees that a driver is signed in, but they haven't gotten updates in a while, then they're unable to schedule rides. And so this will automatically kick off an SMS notification to the driver. They'll ask, hey, are you out of range? Are you still accepting rides? And frequently what happens is if the driver just moves their car into an area with a better signal, the updates are restored, and they can now get rides scheduled again. So this has really helped Lyft with driver frustration and driver utilization. So Twilio has been very critical in Lyft composing its user communication experience the way it needs to create this sense of security and community. And if we think about Lyft's configuration needs, they have to provision numbers for all of the rides that go on Lyft. Then they need to connect the drivers with the riders, then disconnect them after the ride. Then they need to initiate a new connection in case of a lost and found item. all of this could be very cumbersome because of the way the Twilio API was designed with minimal configuration needed, and all of the configuration can be done through the API. They're actually able to do this on the fly as it's needed, and all of this configuration is handled by the Lyft application itself. So this is another way that Twilio has made a difference for Lyft to be able to service their customers through the API. So Code for America is another really interesting example of a Twilio customer. They're shown here in their offices in San Francisco. If you don't know, Code for America uses technology to make government services better. And they've used Twilio in a number of their projects to help create better communication experiences for the citizens who use these services. So the Balance application was started in California to help users of nutrition assistance or food stamps who usually get an electronic benefits card that has their funds on it. So what happens is what happened formerly is the user would get to the grocery store and wouldn't know exactly how much was on their card. So they'd get all the way to the cash register only to find out that there wasn't enough funds available to cover the groceries that were in their cart. So Code for America solved this problem by creating a simple application where you can text in your card number, and you'll receive a text message back from the Balance API with exactly how much funding you have. So then they can use this as they're walking into the store and know exactly how much they have left to spend on groceries. So this Code for America example, this Balance example, is actually a good example of the low friction access component of the Twilio API that John had talked about. Essentially, all that was needed to get started iterating and experimenting with this service is a Twilio phone number and a URL to respond to incoming texts. Code for America could get started easily and quickly and end up building something that makes a difference for thousands of citizens and the way they use their benefits every day. As of today, I understand that the Balance has done over 20,000 Balance checks, and it's really made a difference in the way citizens use their services. So an example from our partner community is VoiceIt. VoiceIt is a REST API for voice authentication. It's a pretty simple API with 10 API calls, and it creates a voice print for each user for authentication purposes. So VoiceIt and Twilio can actually be used together to create voice authentication into, for example, an IVR, a web or mobile app, or let's just say maybe for a bank. So if we have this customer, in this example, if we have a customer that wants to get access to her phone banking system using voice authentication, here's how it could work. First, she would have to call in and authenticate and enroll in the VoiceIt service. So VoiceIt would ask her to record her saying, a standard catchphrase. Once this enrollment has happened, now, we'd be ready to authenticate. So then when she wants to get access to her bank, she calls into the Twilio number that's associated with the banking application. The bank recognizes her phone number and uses Twilio to prompt her for a voice recording, for a voice sample that can be used to authenticate against. It then sends this voice sample to the VoiceIt API. And then once the VoiceIt API returns that the authentication has passed, she's then given access to her system. So VoiceIt is, let's see. Oh, I went backwards. So here's VoiceIt. So VoiceIt is another example in the Twilio partner community of how you're not just limited to the functionality that Twilio provides. We built the API to be composable so that you can use components that are available in the market, other APIs, to build exactly the customer experience that you need. So we've just given you an example of how we built the Twilio API to make anything possible, and a few specific customer examples that show interesting ways in which the API was used. And really, the next step is up to you to dream up what you want to build next. Thank you very much.